So if you turn to page 44, and let's see, my notes are a little bit different than yours, but we can highlight. Whoops, that's not highlighted. Sometimes you get the same x-intercept happening more than once. And when you have something happen more than once, your graph acts a little funny at that point. Not funny because you've seen it already. Like for example, if I got you to graph f of x minus 1 squared, you would just take a parabola and move it 1 to the right. Does it make sense that it has only one x-intercept? But if you looked at its factors, it has x equals 1 twice. So we say it has a multiplicity of 2 because the x-intercept, even though there's only one of them, in its factors, it appeared twice. And if you had x minus 1 cubed, well, that would just take your regular x cubed graph and move it 1 to the right, giving you an x-intercept there. But this one, we would say, has a multiplicity of 3. Now, in the multiplicity of 2, our graph touches that x-intercept and kind of bounces off of it and goes back up. So far, all the examples we've done with x-intercepts of multiplicity of 1, if it had a multiplicity of 1, like this graph right here, had 4 x-intercepts with multiplicity of 1 because they each happened only once, your graph just goes straight through those x-intercepts. And that's what we're used to so far, just drawing straight through. But we're finding out that if it has a multiplicity of 2, it bounces. And if it has a multiplicity of 3, like an x cubed graph does, it bends and flattens out at the x-intercept before going back up again. So, beside these two graphs, we're going to add some notes. We're going to start off with even multiplicity. That means you have an x-intercept that's squared, or an x-intercept that's to the power 4 or power of 6. Anything that happens an even number of times. And this is not a mathematical word. That's why I put it in quotation marks. But it really describes what happens. It just bounces off that x-intercept. It does not go straight through. Then odd multiplicity if it happens only once, that's an odd number, right? If the exponent is 1, if you have an x-intercept happen only once, the graph goes straight through. Technically, sometimes people don't list this in multiplicity because multiplicity sort of implies that it happens more than once. So we could sometimes just ignore this, but it's good to put a note. But any other odd number, like if you have an exponent of 3, exponent of 5, exponent of 7, if the same x-intercept happens 3 times, 5 times, 7 times, again, these are not mathematical words. The graph bends or flattens out. Mathematical word would be stationary point of inflection. But you have to take calculus to talk about those words. That's next year. So the graph bends or flattens out at the x-intercept. In fact, if we would look back at our x-cube graphs that you guys drew in transformations, I probably should take off half marks off every one of them. Because you definitely have the bend, but I don't think you have the flatten out. So if we think about an x-cube graph, if I drew this as an x-cube graph, you'd say, yeah, that looks like an x-cube graph, but it's technically not flat enough. I've got a little bit of a bend there, but I technically should, sometimes I even tell students, draw the dot, draw a tiny little flat line. Oh my goodness, my pen is not happy with me. I'll start up here. And then draw your graph. Because it needs to flatten right out, like just for one little tiny moment, it flattens perfectly out. So when drawing it, we probably, with our x-cube graphs, even if you look back at my x-cube graphs, you could be like really critical. Oh, Mr. JR, you didn't draw it flat enough, did you? Yeah, I probably didn't. So this is how the last thing that's going to help us graph. We're going to draw all of our x-intercepts. We're going to think about our end behavior, and then we're going to add bounces and things flattening out if that happens. So when we go to example 3 now, and they were so nice to us, they already factored it. So we don't have to go through that last long step. But if it's already factored, sometimes it's a little bit harder to see the end behavior. If you multiply this out, what would be the very first term? I don't care about any of the rest. Dot, 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 dot. But if I multiply this out, what is my very first term? And if you think about it, your very first term, just like foiling, but you have a bunch of them, you have a bunch of insides, outsides, lasts, your first ones all get multiplied out to become your first term. If I wrote this out, this is x plus 1, x plus 1, x plus 1, x plus 1, 4 times, right? And then x minus 2. Can you see if you multiply all of your first ones together, you would get an x to the 5. Which means your end behavior acts like a line, opening, starting bottom left, going up to top right. If it's written this way, your y-intercept is a little bit more difficult. Not a lot, but a little bit more difficult. Again, plug in 0 for x, and you might have to do some math. Usually if it's written the long way, everything goes away and it's just the last number, right? But this time, 0 plus 1 is 1. You have to do 1 to the 4 in your head. That's 1. And then you have to do 0 minus 2, which is negative 2. And then you have to take that 1 and multiply it by your negative 2, and you will get your y-intercept at 0, negative 2. Actually, wasn't too hard mental math, but you have to be careful. And I will tell you that you will make mistakes in your y-intercepts. And then when you try to follow the rules with bounces and bends and end behavior, and things don't work, you know you made a mental math error somewhere. Don't force it to work, because then you're bound to lose comprehension marks at that point. So instead, check over your x-intercepts, check over your y-intercepts. In this case, in A, our x-intercepts, we're going to have negative 1, comma 0, and 2, comma 0. And in this one, has a multiplicity of 4, and this one has a multiplicity of 1. So how does this all come together and help us draw something accurately? Well, I'm going to start my graph here so it stays on the same page. I'm I'm going to label my y-intercept. And even if you make dashes, if you don't label that point, you lose that E9 error because they could say, oh, you could have been going by 2s. You'd be like, it was obvious I was going by 1s, but no, they will take off that E9 error if you haven't labeled it explicitly. So I label 0, -2. I've got -1, 0, and 2, 0. I know that my end behavior, I'm going to have to start from down here. This one is a bounce. This one, now you can do this kind of labeling if you want to help remind you. I would probably just look at the numbers and say I know what to do, but sometimes we forget. So because the multiplicity of 4, that one has to be a bounce. Because of the multiplicity of 1, it has to go straight through that one. I need to start my end behavior. I need to start down here. Then I come up, I'm like, oh, I got to bounce off. And straight through. Notice how I went a little bit lower, just because I wanted it to flow nicely in between my points. My end behavior, does it match up? Yes, it does. Do I have the bounce and the straight through? And did I nicely go through all of my points? Okay? So here is a common mistake. Common mistake is you forget a negative. So I am common student with a common mistake, and I made the common mistake of I somehow forgot a negative with my y-intercept, so I had these 3 points labeled as my x-intercepts and y-intercepts. You can see that this one is wrong, because we did it right, but this is what you had. How does the graphing tell you you made a mistake, and that you should check things over? So you're going to start down here, you're like, I know this is a bounce, and then, oh, I have to go through this point. Oh, okay. You just invented new x-intercepts. If you invent a new x-intercept, you absolutely made a mistake, because you found all the x-intercepts. When we factor and when we solve, we find all the x-intercepts. You cannot invent new ones, even though you might feel like I have to go through all the points. This told you something went wrong, and you should double check each of your points. So it's just a common, it's like the question is built in to tell you you've made mistakes. And sometimes you're like, I don't need a question to tell me that. I know that I make mistakes. But it's kind of helpful because that little tiny switch, right? This would probably lose you 2 marks on the question. You've got your wrong y-intercept, lose a mark there. Then you invented new x-intercepts, lose a mark there. One little change fixed one little easy mistake. Oh, I just forgot a negative. And now you've got those 2 marks back. All right, let's look at B. Again, B is already factored, but if, here I'll just rewrite it out. So it's given to us like this, negative. And I'm going to do what I did last time. You don't have to do this, but if you wrote it all out like that, and you expanded this, you see you have 1, 2, 3, 4 x's as your first terms. That would give you an x to the 4, but you also have a negative out in front. That would still be a negative out in front, because this negative out in front is like a -1. So I know it's going to end behavior, act like a parabola, and open down. My y-intercept, again, since it's already factored, we have to do a little bit of math. Okay? This is going to be a negative. If I plug in 0 for x, this first thing, maybe I even show that. It's not bad. I can do it in mental math, but if I plugged in
Sorry for the interruption, just a reminder that there is a mandatory meeting for the Blue Knights team after school today in room T2B1. That's all Blue Knights. Please go to 2B1 after school today.
Alright, if I plugged in 0, this would be 1, it still gets cubed, this would be -3. It isn't hard mental math, but it is extremely easy to make an error. Order of operations, you do the 1 first. 1 cubed is 1. Times a negative will be -1. Times a -3 will be +3. If you're going to make a mistake, it's going to be in your y-intercepts there with simple mental math. Okay? X-intercepts, it was already factored, super nice of them. We get -1, 0. That one has a multiplicity of 3. And put in brackets, that's going to be a bend and a flattened out. And the other one is at 3, 0. That's going to go multiplicity of 1. That's going to go straight through. So our graph. We have y-intercept at 0, 3. X-intercept at 3, 0. And -1, 0. At the -1, 0, I'm going to draw a little tiny flat line, because I know that it has to flatten out there. Okay? Make sure that I get my bend. And at the other one, it's straight through. What's my end behavior? It's starting down here. Starts down here, connect to the one flat line, go through the other flat line, straight through. And this is quite an accurate graph of what it looks like. What don't I know? I don't know how high it goes. I picked my maximum so that it would make a smooth curve through it. I've got my bend, right? So in these questions, they're like, look at that x-intercept. It's supposed to have a bend. If it doesn't have a bend, it's an automatic 1-mark deduction. That's an important concept. And now we can graph things quite accurately with just x-intercepts, y-intercepts, and end behavior. And that's all that's going to be expected from you. So you can circle questions 9 to 12.